In this video, we are going to look at another quadratic application word problem. This problem tells us that a rectangular nuclear waste holding facility is 100 meters long and 70 meters wide. A uniform width safety zone strip must be constructed around the facility. Determine the width of the strip of land to the nearest meter if the area of the facility and the strip is 90,000 meters squared. So the first thing I'm going to do is draw a diagram to help understand what this question is asking. So here I have drawn the rectangular nuclear waste facility with the dimensions 100 by 70, and then I drew a uniform width safety zone around. So a rectangle inside a rectangle. We are told that the width of the safety zone strip is uniform. We don't know what that width is, so I called it width x. So this means the larger rectangle has a length of 100 plus 2x because there's a width on either side. So it's this x here plus the 100 plus the other x. And then the width is 70 plus 2x. So we have the dimensions for the small rectangle, 70 by 100, and the larger rectangle, we have 100 plus 2x by 70 plus 2x. We now need to determine if this is a value problem or a maximize or minimize problem. So here, the question asks to determine the width of the strip of land to the nearest meter. So we are trying to find this value of the width. We are not asked to maximize the area. We're not asked to minimize the area. In fact, we are given what the area is. So this is a value problem, which means I'm either going to factor or I'm going to use the quadratic equation to find the x value. So in these problems, we need to set up an equation. So we have our diagram, and the other piece of information we've not used yet is the area of the entire facility and the strip. So this large rectangle. We already talked about the length and the width. So we are going to use the formula area of a rectangle is length times width to find an equation using our x values. So we get the area, which is 90,000, the length, which is 100 plus 2x, and the width, which is 70 plus 2x. We now need to solve for x. To solve, we either factor or we use the quadratic formula. Now, this equation might look like it's in factored form because there's two brackets. However, it does not equal 0. We always need an equation to equal 0 to solve that equation. So what we need to do is expand these brackets and then bring the 90,000 to the right side, so the left side will equal to 0. So I'm now going to multiply these brackets through to get 4 terms. So when I do that, I get 100 times 70 is 7,000, 100 times 2x is 200x, 2x times 70 is 140x, 2x times 2x is 4x squared. So now I'm going to simplify this quadratic by collecting like terms, these two terms here. I'm also going to bring the 90,000 to the right side and again collect like terms with the 7,000. And when I solve quadratic equations, I like it to be in the form ax squared plus bx plus c, so I'm going to move that 4x squared term first. So when I simplify and rearrange, I get the 4x squared from the line above. The 200x plus 140x is 340x. 7,000, take away the 90,000 is negative 83,000. And the left side is equal to 0. Again, it is important to highlight that you must make this equal to 0 before solving this equation. So now to solve, I'm going to look to see if I can take a common factor. And it looks like I can. Just check to see if you can divide each term by 4. If you get a decimal when you divide by 4, you should be using the quadratic formula. But here I don't. I actually can take a common factor of 4. So I get 4 bracket x squared plus 85x minus 20,750. So now you look inside the brackets and you see a simple quadratic equation You try to factor this if possible, but it does not look possible. This C term is quite large, so I am going to use the quadratic formula to solve. So here I'm going to say A is 1, B is 85, and C is negative 20,750. So I'm going to substitute that into my quadratic equation. You could have also substituted in A is 4, B is 340, and C is negative 83,000. You would get much bigger numbers that you're working with in the formula. However, you will get the same answers as how I would do it with these A, B, and C values. So when I substitute into the quadratic formula, I get negative 85 plus or minus the square root of 85 squared minus 4 times 1 times negative 20,750, all divided by 2 times 1. I'm now going to simplify inside the square root, and I get the following. I get x equals negative 85 plus the square root of 90,225 divided by 2, and x equals negative 85 minus the square root of 90,225 divided by 2. We can now solve for x by putting each into our calculator. So my first answer, when I put this in, rounds to 108, and my second answer rounds to negative 192. So finally, we should just reread the question again, remind ourselves what we are looking for, which is the width of the safety zone strip around the facility. Because we are looking for a width in context of this problem, we know our negative solution is not possible. Therefore, we can state that the width of the safety zone strip is 108 meters.